I'm Tyler Reid, Manufacturing Specialist at GoEngineer. Today I will be talking about multi-stepped holes inside CAMWorks. CAMWorks is a feature-based CAM that finds 2.5-axis features for us. Features like holes, pockets, slots, and bosses. One of those feature types is what we call a multi-stepped hole, and I have an example, 3 of them, in this part here. I've colored the faces of one of the features to help us in our discussion. Multi-stepped holes, to be honest, are a feature that can be confusing and a little bit aggravating for a new user. But I'm going to help you over the next few minutes learn to spot multi-stepped holes and know when to make the decision to program them inside the technology database or to program them manually. So the first thing I'm going to do in this part is I'm going to run feature recognition and allow CAMWorks to find the 2.5-axis machinable features. So if we look in the feature tree, we see that it found a hole, this MS hole group, which is what we will be talking about today, counterbore hole group, and some pockets for the engraving up at the top. I'm going to go ahead and delete the features that we are not concerned about. So let's take a look at this MS hole group. Undoubtedly, if you use CAMWorks, you've seen an MS hole group come in through the automatic feature recognition. And when you take the next step and you generate an operation plan and actually run that feature through the database, you may have seen a message like this. The machining diameter or depth defined in the TechDB is 0. And I'm going to click OK, and I may see more of those. And then it kicks me over into the operation tree, and I have all sorts of operations that, to be honest, make no sense. I have a couple thread mills in here. Who knows what's going on? And that's a common reaction for a new user. So what is a multi-stepped hole? Let's take a look at a counterbore hole first. Counterbore hole is really a circular pocket and a drilled hole. We call this one step. A multi-step hole could be defined as a counterbore hole with more than one step or some chamfers. So SAE ports or other types of ports are very common multi-stepped hole features. Sometimes CAMWorks will find multi-stepped hole features when they are not actually multi-stepped holes. Or in the case of an SAE port, it might be a multi-stepped hole geometry that you cut often. So there are different scenarios when a multi-stepped hole could come into play. In this case here, I have some ports that I'm going to be cutting on this part, but I'm also going to be cutting them often on other parts. So I'm going to take the time to program these multi-stepped holes into my technology database. If I have some geometry that just happens to be found as a multi-stepped hole, or if it's a geometry that I don't plan on cutting again or very often, I would probably go through and program it manually just for the one time. Let's take a closer look at this multi-stepped hole feature. We'll do a cross-section view so we can see the geometry. I'm also going to double-click on the MS hole group feature in the CAMWorks feature tree. When I double-click that, I will get a pop-up that lists the attributes of this particular multi-stepped hole. It also displays the strategy that we have selected. In this case, it's just the default strategy, MSH1. So in this hole, we have one cylinder, a second cylinder, a chamfer, cylinder 3, and cylinder 4. So it's actually just looking at the different steps and labeling them cylinder 1 through 4 and chamfer 1. This is important for us when we go back into our technology database and we set up a custom strategy for this multi-stepped hole. Now again, if this was a geometry that I don't plan on cutting often or ever again, I would program all of these manually. And what I mean by that is I would delete this MS hole group and I would manually create a pocket feature a second pocket feature, maybe a hole feature here, and a third pocket feature here. I'm going to essentially do the same, but I'm going to do it in the TechDB so that we can program these ports in the future. So let's take a look at the technology database. You'll find MultiStepped Holes listed under Mill, Features and Operations, MultiStepped Holes. Take a look at this window. At the top, we have MSH1 designated as the strategy. Now remember, that's the strategy that we had selected. That was the default strategy that came out of the database. The operations for the matching conditions lists all of the operations that are going to be created for that particular multi-step hole strategy. So if we look here, we have about a dozen different operations that would be created. Within each operation, we have what cylinder it's cutting, how deep it's going, what tool it's using, etc. So remember when we first ran feature recognition and we generated an operation plan, we got some pop-ups listing the machining depth as 0. What we were seeing here are cylinders are actually operations tied to cylinders that may not have existed. So if we had a cylinder that was labeled cylinder 4 or cylinder 5, and we don't have 5 cylinders in our multi-stepped hole, that's going to cause an issue. Here's our thread mills that we saw. That's where those came from. This default multi-stepped hole strategy, we won't be using it in this video, and you probably won't be using it at all. You could go ahead and delete this strategy, or you can just create a second one. You would delete a strategy by selecting this tall light blue box and hitting delete. You can create a second strategy, or a third or fourth strategy, by clicking over to the next record in the bottom left-hand corner. So I'm going to create a second one. I'm going to go ahead and name this SAE port, and I will give it an arbitrary name. Now what I'm going to do is I'm going to have to program that port manually, but I'm going to do it inside the database so that it's accessible in the future. So the way I'm going to do that is I'm going to take a look at my port, and I'm going to try to predict how I would cut this. What tools would I use? What operations would I use? And in what order those operations would be in. I have to tie those operations to specific cylinders. So it's going to count from top to bottom, cylinder 1, 2, 3, 4, and chamfer 1. So I believe the way I would program this is I would maybe mill out cylinder 1, center drill, and then drill all the way through cylinder 4 to remove the center section. Then I would rough out cylinder 2, cylinder 3, and then come in with a counter bore, or countersink I should say, and hit this chamfer. So that's the way I'm going to program it. I'm going to choose an operation that to start with. We'll say a rough mill. Within that rough mill, I can adjust all my operation parameters. I don't plan on doing a finish pass, so my allowance, my side allowance, I'm going to set to 0. I'm also going to do a spiral out pattern. Make sure when you choose spiral out that you have cleanup pass check marked. I'm going to go ahead and close that. Now it's time to set the diameter. So what I'm doing here is I click the little icon next to the text box, and it brings up a pop-up window. And we're going to set the diameter. The diameter of this feature is going to be dictated by the diameter of cylinder 1. The face depth is already set to the top of cylinder 1, so this, starting at the top and moving downwards, the face depth would be the top of the feature. So top of cylinder 1 is great in this case. The machining depth, we're actually going to change that to the bottom of cylinder 1. And then for the tool, we will select the tool. And I'm going to choose a 3/8 inch flat end mill from my tool crib. Okay, so now I have my first operation. If I'm unsure about the tool selection, I can always use an expression to set up a low and high range and allow CAMWorks to pick a tool based on the size of that cylinder from the tool crib. But in this case, I'm going to just select a tool here. The next step, refreshing my memory, we're going to center drill in preparation for drilling all the way through cylinder 4. So I'm going to choose a center drill operation. The diameter is actually going to be based on cylinder 4. I'm taking the smallest cylinder in the feature. The face depth is going to be the bottom of cylinder 1 because I have milled out that cylinder at this point. So that face will be exposed. The depth, for a countersink, I can actually just set a diameter created by the countersink. So that's what I'm going to do. I'm going to specify a countersink diameter of 50 thousandths. And then for the tool, again, I will just select a tool from my tool crib. A number 3 countersink should work. Now that I've done my center drill, I can do a drill. Again, the drill will be tied to cylinder 4, the diameter. The face depth will be the bottom of cylinder 1. The machining depth will be the bottom of cylinder 4. So that means we're going to be going through cylinder 4. And I'm also going to add the tip length because that's a through hole. And then on the tool summary, I actually am going to create an expression this time. I'm going to create a lower bound. So we'll say the diameter of cylinder 4 minus 5 thousandths. And then the upper expression, we'll leave it at the diameter of cylinder 4. So what that is doing is it's creating a range for CAMWorks to go, a range of diameters for CAMWorks to go into our tool crib and choose a tool, a drill, with a diameter that fits this range. So it's basing the tool selection on the size of the cylinder. So that should give me the first counterbore and a hole drilled down through the center of my port. The next portion that I will be machining is cylinder 2. So we will rough mill that out as well. And we'll go through and choose our spiral out, our 0 side allowance. This will be based on cylinder 2. The face depth will be the top of cylinder 2. And the machining depth will be the bottom of cylinder 2. And the tool selected, switch back over to CAMWorks, and we will double click on the MultiStepped hole. And if I want to know the diameter of cylinder 2, I can highlight cylinder 2 and it's going to give me the diameter as 5/8 of an inch. I'm going to want to cut cylinder 3 with the same tool if possible. So cylinder 3 is a diameter of 1/2 inch, so I'm going to choose a tool that would fit the smaller cylinder as well. So let's just choose a 1/4 inch tool, 1/4" flat end mill. Okay, so that's cylinder 2. Now let's hit cylinder 3, again with a rough mill. We'll just repeat the steps. Diameter based on cylinder 3. Face depth, top of cylinder 3. And the machining depth of the bottom of cylinder 3. And we will go ahead and choose the same tool that we did for the previous step. Okay, so just walking us through the steps here, I'm roughing out the first counterbore. I'm doing a center drill and a drill down through the entire port. We're going to be roughing out 2 sides, cylinders 2 and 3. And then the last bit of geometry that we're going to need to cut here is this chamfer. So that chamfer will be listed as a countersink operation. The diameter is actually going to allow us to select chamfer 1. The face depth, this is actually going to be a little tricky here. We're going to use the bottom of chamfer 1 as opposed to the top of the chamfer. Okay, and then for the depth, we will control the depth by the countersink diameter. Let's hop back over to CAMWorks. That countersink diameter created, because I'm tying this to the bottom of the countersink, we're going to use this bottom diameter. And it looks like the radius is a 1/4 inch, so the diameter is a 1/2 inch. So we will use 0.50. And then for the tool size, I could use an expression here. Again, I could also select a tool. The tool I'm going to select here, 90 by 5/8. Now here's the moment of truth. I've gone through and I've gone back and forth between the TechDB and CAMWorks a little bit. I think I have it set how I want. So I'm going to go ahead and close this and exit the TechDB. Back inside CAMWorks, I don't have to rerun feature recognition. I can simply double click on the whole group and change my strategy selected here. So here's my SAE port. And now I'm going to right click and generate an operation plan. I'm telling it to rerun through the database. I want to click regenerate here because that will force it to relook at the database entries and rewrite all of the operations. So I'm going to click regenerate. Here are the operations that I created. We have a rough mill, center drill, 2 more rough mills, and a countersink. I'm going to go ahead and generate the toolpath here. Looks like one of my rough mills stayed pink. So there might be an operation parameter that I have selected in there that's keeping that tool from cutting, or there might be a mistake in my TechDB definition. So let's take a second look at what I have in the technology database. For that second rough mill, I have the top of cylinder 3 to the bottom of cylinder 3. So the depth looks correct. Looks like it didn't like to spiral out. So Based on my tool size and the parameters of the spiral and the step over, looks like my operation parameters didn't quite work out. So I may want to go back into the technology database and adjust those. So now that I have toolpath on all portions of this port, I will simulate this. Once the simulation is finished, I will run the comparison tool, and we have all green. So that means everything is machining correctly. It's machining to size. I have the order correct. And now I have a port strategy that I can easily access in the future. So very quickly, I'm going to close this part and reopen it and demonstrate how I would use this in the future. We'll simply reopen this, rerun our feature recognition. Now it finds the MS hole group. It's up to me as the programmer to double click this and change my machining strategy. Now when I run this through the database and generate my toolpaths, I have good toolpath, and this is easily accessible in the future. I still have that spiral out option, so I'm going to go ahead and quickly jump back into the database and change that, and then we're good to go. So if this is a port that I'm going to cut often, it is in my best interest to program this into the database, because that way it gave me 6 different operations that with 1 or 2 mouse clicks, I can repeat. If this is a multi-step tool that I'm not going to cut often, I would just simply go through, delete the multi-step tool feature, create pocket features, create hole features, and whatnot. So let's jump into this. There we go. I won't have to deal with that spiral out option anymore. And that's how we deal with multi-stepped holes inside CAMWorks. Thank you for watching, and let us know if you have any questions.